Hello everyone, I am Dr. Rangnath Haridas working as Assistant Professor in SVERI's College of Engineering, Pandharpur. So today we are discussing one of the topic related to physics. It is electrons and photons. So of course this video lecture is divided into two parts. First we are checking the basic terms and equations related to electrons and photons. Next we are solving different MCQs, that is numericals. So let us start these electrons and photons. So electrons and photons, when we are discussing, so in this chapter it is related to photoelectric effect, that is Einstein's photoelectric effect, and dual nature of matter and radiation. So we check first what points we are covering, what is meant by photons, then photoelectric effect, how this photoelectric effect takes place, experimental setup to study photoelectric effect. Next is effect of intensity, frequency, potential on photoelectric current. Next is graphical representation of variation of photoelectric current, laws of photoelectric effect, then Einstein's photoelectric equation. Next is verification of laws of photoelectric effect based on Einstein's photoelectric equation. Next is application of photoelectric effect, and last one, matter waves and de Broglie wavelength. Division and German experiment is we are covering in our next lecture or next chapter. So let us discuss this point one by one. So first is photon. So what is meant by photon, that we have to discuss, and after that we are checking these equations in terms of properties. What is meant by photon? Its properties, different properties are there. So let us check these things one by one. So photon is nothing but a packet or bundle of energy that we are calling as a photon. So it is an energy packet which is having energy. What is its energy? It is given by energy of a photon is E is equal to h nu, or you can write this as hc by lambda, where h is Planck's constant, nu is the frequency of the radiation or photon, c is the speed of light, that is electromagnetic wave, and lambda is the wavelength. So if we check the equation, that is E is equal to h nu, or simply we are converting that frequency into c by lambda, where h is Planck's constant, we are taking that value which is constant 1, then nu is frequency, or we can write that in terms of speed of light divided by wavelength. Now let us check different properties of photons. First, a photon travels at a speed of light, that is c in vacuum. Its value is 3 into 10 raised to 8 meter per second, or 3 into 10 raised to 5 kilometer per second. That is the velocity of light. It is 10 to the power plus 8. Okay. Then second is it has zero rest mass. That is, the photon cannot exist at rest. So it is having zero rest mass. Next property, the kinetic mass of a photon is, we are writing in terms of value m, that is m is equal to e by c square, or h divided by c into lambda. The momentum of a photon is p, that is mv is equal to e by c or h by lambda. So we have to check these terms at our last slides, how we are writing that as a p is equal to h by lambda by comparing two equations. that is E is equal to h nu and E is equal to mc square. Next property, photons travel in a straight line. And next one is energy of a photon depends upon frequency of the photon. So the energy of photon does not change when photon travels from one medium to another. So these are some of the properties. We can add the next property and then we will discuss. Next is wavelength of the photon changes in different media. So velocity of a photon is different in different media. Next is photons are electrically neutral. Next, photons may show diffraction under given conditions. And the last one is photons are not deviated by magnetic and electric fields as they are electrically neutral. So let us check these terms once again, that what is meant by photon and what are its properties. Photon म्हणजे काय तर a packet of bundle, a packet or bundle of energy. तर एनर्जी पॅकेट आहे फोटॉन म्हणजे ज्याच्या प्रॉपर्टीज आहेत काही, आपण ती जी एनर्जी आहे फोटॉनची ती कशा स्वरूपात लिहितो किंवा मांडतो तर E इज इक्वल टू म्हणजे एनर्जी जी आहे फोटॉनची E इज इक्वल टू h न्यू किंवा त्यालाच आपण hc बाय लॅम्बडा या स्वरूपात सुद्धा दाखवतो. यामध्ये प्रत्येक टर्मचं मीनिंग काय आहे तर E म्हणजे एनर्जी, दॅट इज एनर्जी ऑफ फोटॉन. h म्हणजे काय तर प्लँक्स कॉन्स्टंट. nu is the frequency of the radiation of photon. c म्हणजे velocity speed of light, electromagnetic wave आहे. and lambda is the wavelength, त्याची wavelength आहे त्याला आपण लॅम्बडा असं म्हणतो. आता वेगवेगळ्या जर प्रॉपर्टीज त्याच्या बघितल्या तर फर्स्ट प्रॉपर्टी काय, एक फोटॉन ट्रॅव्हल्स ॲट ए स्पीड ऑफ लाईट c इन व्हॅक्यूम. व्हॅक्यूम मध्ये त्याचा स्पीड, लाईटचा स्पीड आहे 3 × 10⁸ मीटर पर सेकंड. नेक्स्ट, इट हॅज 0 रेस्ट टू मास. रेस्ट टू मास आहे तर त्याचं काय 0 आहे. त्यानंतर कायनेटिक मास जे आहे फोटॉनचं तर ते आपण कसं लिहितो तर m इज इक्वल टू e बाय c स्क्वेअर किंवा h डिवायडेड बाय c इंटू लॅम्बडा. मोमेंटम जे आहे फोटॉनचं तर ते मोमेंटम p इज इक्वल टू e बाय c किंवा h बाय लॅम्बडा असं आपण लिहितो. तर हे आपल्याला चेक करायचं की हे इक्वेशन आपण कसं मिळवलं तर E इज इक्वल टू h न्यू आणि E इज इक्वल टू mc स्क्वेअर हे जे दोन इक्वेशन आहेत त्याचा यूज करून आपण p मीन्स mv इज इक्वल टू e बाय c किंवा h बाय c ही व्हॅल्यू आपल्याला मिळते. देन फोटॉन्स ट्रॅव्हल इन अ स्ट्रेट लाईन. स्ट्रेट लाईन मध्ये ते ट्रॅव्हल करतात. एनर्जी ऑफ ए फोटॉन डिपेंड्स अपॉन फ्रिक्वेन्सी ऑफ द फोटॉन. फ्रिक्वेन्सी वर त्याची एनर्जी डिपेंडेंट आहे. त्यामुळे ती वन मीडियम टू अनदर जर ट्रॅव्हल झाली तर ती एनर्जी तशी आहे, त्याची फ्रिक्वेन्सी जी आहे तर ती कशावर डिपेंडेंट आहे तर त्या एनर्जीला आपण कन्सिडर करतो त्या फ्रिक्वेन्सीशी रिलेटेड. देन नेक्स्ट प्रॉपर्टी आहे वेवलेंथ ऑफ फोटॉन चेंजेस इन डिफरंट मीडिया. जसं मीडियम चेंज होईल तसं वेवलेंथ जी आहे तर ती चेंज होते. सो वेलोसिटी ऑफ ए फोटॉन इज डिफरंट इन डिफरंट मीडिया. वेलोसिटी जी आहे फोटॉनची तर ती डिफरंट मीडियाला डिफरंट आहे. फोटॉन्स आर इलेक्ट्रिकली न्यूट्रल म्हणजे काय तर फोटॉन्स हे इलेक्ट्रिकली न्यूट्रल आहेत. जी पुढची प्रॉपर्टी आहे दे आर नॉट डिव्हिएटेड बाय magnetic and electric fields, so it is because they are electrically neutral. Next, photons may show diffraction under given condition. So diffraction effect we are getting in different conditions. So let us move to the next point, that is photoelectric effect. What is meant by photoelectric effect? So the phenomenon of emission of electrons from mainly metal surfaces exposed to light energy, that is X-rays, gamma rays, ultraviolet rays, visible light and even infrared rays of suitable frequency is known as photoelectric effect. The electrons emitted by this effect are called photoelectrons. The current constituted by photoelectrons is known as photoelectric current. So non-metals also show photoelectric effect. Liquids and gases also show this effect, but to limited extent. So in figure, we can check ultraviolet light exposed to metals. We are getting photoelectrons. Then metals or metals other than alkali metals, if we expose, then we are getting not that effect, that is no photoelectrons we are showing if we expose that by visible light. Then visible light exposed to alkali metals, then we can get these photoelectrons. So let us check this photoelectric effect. आपण आधी photons म्हणजे काय आणि photonsच्या प्रॉपर्टी चेक केल्या. आता आपण बघतोय की photoelectric effect म्हणजे काय. तर the phenomenon of emission of electrons. Electrons emit होत आहेत कशापासून? From mainly metal surfaces. Metal surface पासून जर आपण त्याला एक्सपोज केलं लाईट एनर्जीनं, मग ते वेगवेगळ्या प्रकारचे असेल, एक्स-रे असेल, गॅमा रेज असेल, अल्ट्राव्हायोलेट रेज असेल, तर त्या पर्टिक्युलर सुटेबल फ्रिक्वेन्सीला जर आपण एक्सपोज केलं लाईट एनर्जीला, तर आपल्याला जो इफेक्ट मिळतो तर त्याला आपण म्हणतो फोटोइलेक्ट्रिक इफेक्ट. द इलेक्ट्रॉन्स इमिटेड बाय दिस इफेक्ट, जे इलेक्ट्रॉन्स इमिट होतात त्या इफेक्टनं त्याला आपण म्हणतो फोटोइलेक्ट्रॉन्स. द करंट कन्स्टिट्यूटेड बाय फोटोइलेक्ट्रॉन्स इज नोन एज फोटोइलेक्ट्रिक करंट. तो जो करंट आहे फोटोइलेक्ट्रॉन्स मिळतो त्याला आपण म्हणतो फोटोइलेक्ट्रिक करंट. आणि वेगवेगळे कंडिशन्स आपण याच्यामध्ये चेक केल्या ज्याचा यूज करून आपण फोटो इलेक्ट्रॉन्स मिळवतो. सो लेट अस मूव टू द नेक्स्ट वन. सो दिस इज एक्सपेरिमेंटल सेटअप to study photoelectric effect. If we check, we are connected that particular tube in this circuit where metallic cathode and metallic anodes we are using. Quartz window we are using for exposing that metallic cathode by ultraviolet light. It is connected in circuit and we are getting photoelectric current. So glass transmits only visible and infrared lights but not ultraviolet light. So we are exposing that light by quartz window. So quartz transmits ultraviolet light. So when light of suitable frequency falls on the metallic cathode, photoelectrons are emitted. So suitable frequency we have to consider falls on the metallic cathode. What happens? Photoelectrons are emitted. These photoelectrons are attracted towards the positive anode and hence photoelectric current is constituted. Means this photoelectrons gets attracted towards this positive anode and we are getting photoelectric current. So that is nothing but photoelectric effect. या स्लाइड मध्ये आपण काय बघतो? एक्सपेरिमेंटल सेटअप आहे फोटोइलेक्ट्रिक इफेक्ट साठी, ज्याच्यामध्ये मेटॅलिक कॅथोड, मेटॅलिक एनोड आणि क्वार्ट्ज विंडो आपण इथे यूज केलेला आहे. तर अल्ट्राव्हायोलेट लाईट आपण एक्सपोज करतोय जी क्वार्ट्ज विंडो ट्रान्समिट करू शकते. व्हेन अ लाईट ऑफ सुटेबल फ्रिक्वेन्सी आपल्याला कन्सिडर केली पाहिजे. त्या सुटेबल फ्रिक्वेन्सीला जर आपण लाईट एक्सपोज केली मेटॅलिक कॅथोडला तर काय होतं? फोटो इलेक्ट्रॉन्स आर इमिटेड. दीज फोटो इलेक्ट्रॉन्स, हे फोटो इलेक्ट्रॉन्स काय करतात? आर अट्रॅक्टेड टुवर्ड्स द पॉझिटिव्ह एनोड अँड वी आर गेटिंग फोटो इलेक्ट्रिक करंट. आपल्याला फोटो इलेक्ट्रिक करंट मिळतो. So up to this what we have discussed, what is meant by photon, then its properties, photoelectric effect means what, and experimental setup of photoelectric effect. Then we move to the next points where we are checking the graphical representation of effect of intensity of incident light on photoelectric current, effect of potential on photoelectric current. तर इथं वेगवेगळे ग्राफ्स आपण यूज करून हे चेक करणार आहोत की त्याचे इफेक्ट जे आहेत कशाचे, तर इंटेन्सिटी इफेक्ट and potential effect on photoelectric current. So let us discuss. For a fixed frequency, the photoelectric current increases linearly with increase in intensity of incident light. So here we are getting the photoelectric current and intensity on x-axis. So what is written? For a fixed frequency, we are keeping frequency constant. The photoelectric current increases linearly. So photoelectric current we are observing in the graph, it is increases linearly with increase in intensity of light. So as intensity increases, this photoelectric current also increases. Of course, we are keeping frequency fixed. Next, effect of potential on photoelectric current. Now in this case, what we are doing for a fixed frequency once again and intensity of incident light, keeping frequency and intensity fixed, the photoelectric current increases with increasing positive potential applied to the anode. We are increasing the positive potential applied to the anode, and what we are getting, so it shows in the graph. So when all the photoelectrons reach the plate A, current becomes maximum, which is known as saturation current, as shown in the graph. So when the potential is decreased, the current also decreases, but it does not become zero at zero potential. So it reaches up to this point. This shows that even in the absence of accelerating potential, a few photoelectrons manage to reach the plate on their own due to their kinetic energy. Means we are expecting that it becomes zero at this zero potential, but few photoelectrons are managing to reach the plate due to their own kinetic energy, and we are getting some signals. So when negative potential is applied to the plate, then photoelectric current becomes zero at a particular value of negative potential called the stopping potential, or it is also known as cutoff potential. So intensity of incident light does not affect the stopping potential. या स्लाइड मध्ये आपण दोन पॉइंट्स बघतोय, इफेक्ट ऑफ इंटेन्सिटी ऑफ लाईट कशावर, फोटोइलेक्ट्रिक करंट वर, ज्यामध्ये आपण हे चेक केलं की एका पर्टिक्युलर फ्रिक्वेन्सीला इंटेन्सिटी जर आपण वाढवत गेलो तर फोटोइलेक्ट्रिक करंट सुद्धा लिनियरली काय होत जातो, वाढत जातो. इफेक्ट ऑफ पोटेन्शियल, जर पोटेन्शियल आपण बघितलं, सो ऍट फिक्स्ड फ्रिक्वेन्सी अँड इंटेन्सिटी इथे काय होते, जसं आपण पॉझिटिव्ह पोटेन्शियल इन्क्रीज करत जातोय तसं तसं इथे करंट सुद्धा इन्क्रीज होत जातोय. पण इथे कंडिशन जरा वेगळी आहे. यामध्ये सॅच्युरेशन करंट पर्यंत आपल्याला ती व्हॅल्यू मिळते. जर आपण ते कमी करत गेलो तर 0 ला ते 0 होत नाही. सो इट शोज सम व्हॅल्यू. ही व्हॅल्यू कशामुळे दाखवली जाते, तर याचं कारण काय, तर इवन इन द अब्सेन्स ऑफ एक्सेलरेटिंग पोटेन्शियल जरी नसलं तरी फ्यू फोटो इलेक्ट्रॉन्स, काही फोटो इलेक्ट्रॉन्स आहेत तर ते मॅनेज करतायत कुठं, टू रीच द प्लेटला ते जायला मॅनेज करतायत. त्याचे रिझन त्याची कायनेटिक एनर्जी असते. ओके, अँड ॲट निगेटिव्ह पोटेन्शियल इट बिकम्स झिरो, ज्याला आपण स्टॉपिंग पोटेन्शियल किंवा कट ऑफ पोटेन्शियल असं सुद्धा म्हणतो. ओके, so these are graphical representations. We can add another effects, that is effect of frequency of incident light on photoelectric current. So for a fixed intensity of incident light, the photoelectric current does not depend on the frequency of the incident light, because the photoelectric current simply depends on the number of photoelectrons emitted and in turn on the number of photons incident and not on the energy of photon. So simply in case of frequency changes for a fixed intensity, when we are keeping intensity fixed, the photoelectric current does not depends on the frequency of the incident light, because photoelectric current simply depends on the number of photoelectrons emitted. Okay, next is effect of frequency of incident light on stopping potential. So for a fixed intensity of incident light, the photoelectric current increases and is saturated with increasing positive potential applied to the anode. However, the saturation current is same for different frequencies of incident lights. When potential is decreased and taken below zero, photoelectric current decreases to zero, but at different stopping potentials for different frequencies. It means when we are considering the effect of frequency of incident light and effect of frequency of incident light on stopping potential, तर यामध्ये मगाची जर आपण केस कन्सिडर केली ज्यामध्ये आपण फ्रिक्वेन्सी फिक्स्ड ठेवली होती आणि इंटेन्सिटीचा काय इफेक्ट होतोय आणि पोटेन्शियलचा काय इफेक्ट होतोय हे आपण चेक केलं. या केसमध्ये आपण काय करतोय, फ्रिक्वेन्सी व्हॅरी करतोय आणि हे चेक करतोय की इफेक्ट काय होतोय. तर फ्रिक्वेन्सीच्या केसमध्ये आपल्याला माहिती की करंट जो आहे फोटोइलेक्ट्रिक करंट तो कशावर डिपेंडेंट आहे, फोटो इलेक्ट्रॉन्स किती इमिट होतात त्याच्यावर. तर ऑफकोर्स ते इंटेन्सिटीशी रिलेटेडच आहे. सो व्हेन वी आर changing the frequency and keeping intensity constant, so we are getting the same thing. So intensity varies, then only photoelectric current varies. And the next point ज्यामध्ये आपण बघितलं की फ्रिक्वेन्सी आपण चेंज करतोय आणि त्याचा इफेक्ट जो आहे तर तो स्टॉपिंग पोटेन्शियल वर काय. So to the next, that is threshold frequency. The graph between stopping potential and frequency does not pass through the origin. It does not passes through the origin. It shows that there is a minimum value of frequency called a threshold frequency, below which photoelectric emission is not possible, however high the intensity of incident light may be. It depends on the nature of the metal emitting photoelectrons. So what is meant by threshold frequency? So it shows that there is a minimum value of frequency called a threshold frequency, below which photoelectric emission is not possible, however high the intensity of incident light may be. That is called as threshold frequency. It is shown by this graph at this value. Now laws of photoelectric emission. What are the different laws? For a given substance, there is a minimum value of frequency of incident light called a threshold frequency, below which no photoelectric emission is possible, howsoever the intensity of incident light may be. Next is the number of photoelectrons emitted per second, that is photoelectric current, is directly proportional to the intensity of incident light, provided the frequency is above the threshold frequency. Third one, the maximum kinetic energy of the photoelectrons is directly proportional to the frequency, provided the frequency is above the threshold frequency. Next, the maximum kinetic energy of the photoelectrons is independent of the intensity of the incident light. Fifth one is the process of photoelectric emission is instantaneous. That is, as soon as the photon of suitable frequency falls on the substance, it emits photoelectrons. And the last one, the photoelectric emission is 1:1, that is, for every photon of suitable frequency, 1 electron is emitted. Now, from the previous slides, what we are discussing, graphical representation of effect of intensity of incident light on photoelectric current, then effect of potential on photoelectric current, then effect of frequency of incident light on photoelectric current, then effect of frequency of incident light on stopping potential, what is meant by threshold frequency. And then we have discussed these different laws. So let us check these laws once again. The laws काय सांगतात, for a given substance there is a minimum value of frequency of incident light called threshold frequency. Minimum value जी आहे frequency त्याला आपण threshold frequency म्हणतो, below which no photoelectric emission is possible. ज्याच्या खाली photoelectric emission हे possible नाहीये. Next, the number of photoelectrons emitted per second is directly proportional to the intensity of incident light. Intensity जी light ची आहे तर त्याच्यावरच number of photoelectrons किती emit होतात तर ते dependent आहे. The maximum kinetic energy of photoelectrons is directly proportional to kinetic energy maximum जी आहे photoelectrons ची तर ती directly proportional आहे. It is directly proportional to कशावर, the frequency, provided the frequency is above the threshold frequency. Next, the maximum kinetic energy of photoelectrons is independent of the intensity of the incident light. जी kinetic energy आहे maximum, तर ती independent आहे कशाशी related, the intensity of incident light शी related. Then next, the process of photoelectric emission is instantaneous. That is, as soon as the photon of suitable frequency falls on the substance, it emits photoelectrons. Photoelectric emission ही instantaneous आहे, पण ती कशावर डिपेंडंट आहे, तर suitable frequency जर falls किंवा suitable frequency जर पडली on the substance, then and only then it emits photoelectrons. Next is the photoelectric emission is 1:1, that is for every photon of suitable frequency one electron is emitted. So it is the same process called as photoelectric emission. Then we move to the next point, that is Einstein's photoelectric equation. So let us read it first. When a photon of energy h nu falls on a metal surface, the energy of the photon is absorbed by the electron and is used in two ways. First, a part of energy is used to overcome the surface barrier and come out of the metal surface. This part of energy is called as work function, which is given by phi, or you can say energy, that is h nu 0. The remaining part of the energy is used in giving a velocity v to the emitted photoelectron. This is equal to the maximum kinetic energy of the photoelectrons, that is m1/2 mv square max, where m is mass of the photoelectron. According to law of conservation of energy, we are writing this as h nu is equal to work function plus 1/2 mv square max. So the value of work function is h nu 0. After putting and adjusting the term, what we are getting, that is 1/2 mv square max is equal to simply h in bracket mu minus nu 0. So if we see the figure, so here photon having energy h nu is exposed, metal is there, so work function is nothing but to overcome the surface barrier and come out of the metal surface, and the remaining thing is nothing but the remaining part of the energy is used in giving a velocity, that's 1/2 mv square max to the photoelectrons. So let us check this. आपण आता काय डिस्कस करतोय, आइन्स्टाईन्स फोटोइलेक्ट्रिक इक्वेशन, ज्यामध्ये आपण काय म्हटले, when a photon of energy h nu falls on a metal surface वर जर photon आपण जर एक्सपोज केला having energy h nu, the energy of the photon is absorbed by the electron and is used in two ways. दोन प्रकारे जी एनर्जी ऍब्सॉर्ब केली गेली आहे इलेक्ट्रॉन्सना, तर ती दोन प्रकारे युटिलाइज होते. पहिला प्रकार किंवा पहिला पार्ट काय, a part of energy is used to overcome the surface barrier and come out of the metal surface. तर आतलं जे इंटरनल रेजिस्टन्स आणि बॅरियर आहे, तर त्याच्यातून बाहेर येण्यासाठी मेटलच्या सरफेस पासून ती एनर्जी तर ती युटिलाइज केली जाते, ज्याला आपण वर्क फंक्शन म्हणतो, दॅट इज h nu 0. दुसरी काय, द रिमेनिंग पार्ट ऑफ द एनर्जी इज युज्ड इन गिविंग अ वेलोसिटी. त्याला वेलोसिटी v जी आहे, जो इमिटेड फोटो इलेक्ट्रॉन्स आहे, तर त्याच्यासाठी युटिलाइज केली जाते. So we can write that value as 1/2 mv square max, where m is mass of the photoelectron. According to law of conservation of energy, आपण हे कसे लिहू शकतो, तर h nu is equal to work function plus 1/2 mv square max. याला आपण जर ऍडजस्ट केलं तर आपल्याला इक्वेशन मिळतं 1/2 mv square max is equal to h into nu minus nu 0. It is Einstein's photoelectric equation. The next, verification of laws of photoelectric emission based on Einstein's photoelectric equation. So we have to use that Einstein's photoelectric equation 1/2 mv square max, which is equal to h into nu minus nu 0. So let us check these points. So if nu is less than nu 0, then 1/2 mv square max is negative, which is not possible. Therefore, for photoelectric emission to take place, always nu is greater than nu 0. Next, since one photon emits one electron, so the number of photoelectrons emitted per second is directly proportional to the intensity of light. So already we have discussed these things. It is clear that 1/2 m square max is proportional to nu, that is frequency, as h and nu 0 are constant. This shows that kinetic energy of the photoelectrons is directly proportional to the frequency of the incident light. Next, photoelectric emission is due to collision between a photon and an electron. As such, there cannot be any significant time lag between the incidence of photon and emission of photoelectron. That is, the process is instantaneous. It is found that delay is only 10⁻⁸ seconds. So we are verifying the laws of photoelectric emission based on Einstein's photoelectric equation. So different points are there. First point काय आहे तर if nu is less than nu 0 तर काय होतं 1/2 m square max निगेटिव्ह होऊ शकतं, तर ही कंडिशन पॉसिबल नाहीये. याचा अर्थ फोटोइलेक्ट्रिक इमिशन कधी टेक्स प्लेस किंवा कधी घडणार when nu is greater than nu 0. Okay, then the next point, since one photon emits one electron, so the number of photoelectrons emitted per second is directly proportional to the intensity of incident light. म्हणजे थोडक्यात काय तर जे फोटोइलेक्ट्रॉन्स किंवा फोटोइलेक्ट्रिक करंट आहे तर तो कशावर डिपेंडेंट आहे, इट इज डायरेक्टली प्रोपोर्शनल टू इंटेन्सिटी ऑफ इन्सिडेंट लाईट. त्याची जी इंटेन्सिटी आहे इन्सिडेंट लाईटची तर त्याच्यावर तो डिपेंडेंट आहे. नेक्स्ट, it is clear that 1/2 m square max is proportional to nu, as h and nu are constant. H and nu Planck's constant, nu 0 a fixed value आहे. So this shows that kinetic energy of the photoelectrons is directly proportional to the frequency of the incident light. त्याची जी kinetic energy आहे तर ती त्याची फ्रिक्वेन्सी आहे तर त्याच्यावर डिपेंडेंट आहे. इट इज डायरेक्टली प्रोपोर्शनल. नेक्स्ट पॉइंट काय आहे, photoelectric emission is due to collision between a photon and an electron. As such, there cannot be any significant time lag. जो टाइम लॅग आहे तर तो आपल्याला सांगितलेला आहे की साधारणतः 10⁻⁸ सेकंडचा डिले जो आहे तर तो इथं सांगितला. सो वी गो टू द नेक्स्ट पॉइंट. So next is application of photoelectric effect. Different applications are there. So automatic fire alarm we can set by using photoelectric effect. Then automatic burglar alarm, same thing we can use and utilize. Then scanners in television transmission. Then reproduction of sound in cinema film. Next is in paper industry, to measure the thickness of paper you can utilize this photoelectric effect to measure the thickness of paper. To locate flaws or holes in the finished goods. So flaws are nothing but cracks or some disturbances in the structure. So we can use this to locate the finished goods. So polished finished goods are there, so we can use that photoelectric effect to detect the flaws or cracks. In astronomy, we can use that for the different effects related to recording of the space condition, particular area of that cluster of stars or anything what we are recording. To determine opacity of solids and liquids. Then automatic switching of street lights, which depends on once again the effects of exposing the lights to emission of photoelectrons. To control the temperature of furnace. Then photometry. Then to measure the fair complexation of skin. Light meters used in cinema industry to check the light. Photoelectric sorting, sorting of material by using photoelectric effect. Photo counting as a counting meter. And meteorology, that is climatic changes. We can get the different applications related to this photoelectric effect. Then we move to the next part, that is dual nature of radiation in matter, where we are using this de Broglie wave. What is meant by de Broglie wave? And then after completion of this, we move to our Second part, that is MCQ discussion. So let us read it first. Dual nature of radiation and matter. Wave theory of electromagnetic radiations explained the phenomenon of interference, diffraction, and polarization. On the other hand, quantum theory of electromagnetic radiations successfully explained the photoelectric effect, Compton effect, black body radiations, X-ray spectra, etc. Thus, radiations have dual nature, that is wave-particle duality, wave and particle nature. Louis de Broglie suggested that the particles like electrons, protons, neutrons, etc. have also dual nature. That is, they also can have particle as well as wave nature, which we are calling it as a matter wave. So in no experiment matter exists both as a particle and as a wave simultaneously. It is either the one or the other aspect. That is, the two aspects are complementary to each other. So as the nature loves symmetry, the universe is made of particles and radiations, and both entities must be symmetrical. So let us check this. Dual nature of radiation and matter याचा अर्थ काय? तर जे रेडिएशन आणि मॅटर आपण कन्सिडर करतोय ते वेव्ह पार्टिकल ड्युअलिटी मध्ये आपण एक्सप्लेन करतोय. वेव्ह थिअरी जी आहे तर ती इलेक्ट्रोमॅग्नेटिक रेडिएशन एक्सप्लेन करते. फेनॉमेना आपण यूज करतो त्याच्यासाठी इंटरफरन्स, डिफ्रॅक्शन आणि पोलरायझेशन. सर त्याचा यूज करून आपण हे प्रूफ करतो की इलेक्ट्रोमॅग्नेटिक रेडिएशन्स हे वेव्ह नेचरचे आहेत. ऑन द अदर हँड दुसऱ्या बाजूचा जर विचार केला, so quantum theory of electromagnetic radiation successfully explained the photoelectric effect, Compton effect, black body radiation, X-ray spectra. तर याच्यावरून आपण कन्सिडर करतो की हे मॅटर्स जे आहेत तर कशी बिहेव करतात, दॅट इज इलेक्ट्रोमॅग्नेटिक वेव्स अँड मॅटर वेव्स व्हेन वी आर कन्सिडरिंग. तर त्याचा बेस घेऊन लुईस डी ब्रॉगली सजेस्टेड दॅट the particles like electrons, protons and neutrons are also having dual nature, that is wave particle duality. So they also can have particle as well as wave nature. त्यालाच आपण matter waves असं सुद्धा म्हणतो. So in experiment if we check, so both aspects are not exist at a time. So 1 and 2 they are complementary to each other. Next point is this de Broglie wave. So de Broglie wave means what? According to de Broglie, a moving material particle can be associated with a wave. That is, a wave can guide the motion of the particle, or we can say that that motion of particle is like a wave nature. That's why it is called as matter wave. The waves associated with the moving material particles are known as de Broglie waves or matter waves. So its expression, according to quantum theory, the energy of photon, we know that it is E is equal to h nu or hc by lambda. And according to Einsteins relativity of mass and energy mass equivalence equation, we can write that as energy of photon is equal to mc square. So if we compare these two equations, then we are getting these values, that is lambda is equal to h by mc, or h is equal to or lambda is equal to h by p, where p is equal to mc is momentum of a photon. So if you consider, that is instead of a photon, if you consider material particle of mass m which is moving with velocity v, then this equation becomes simply lambda is equal to h by p, that is lambda is equal to h by mv, which is the expression for de Broglie wavelength. तर डी ब्रॉगली वेव्ह आणि त्याची वेव्हलेंथ जी आहे तर ती आपण ते चेक करतोय. त्याच्यासाठी आपण कन्सिडर केलेलं आहे की मटेरियल पार्टिकलची जी मोशन आहे तर ती वेव्ह सारखी आहे, दॅट इज अ वेव्ह कॅन गाईड द मोशन ऑफ द पार्टिकल, किंवा त्यालाच आपण मॅटर वेव्ह असं सुद्धा म्हणतो. द वेव्हज असोसिएटेड विथ द मूव्हिंग मटेरियल पार्टिकल्स आर नोन ॲज डी ब्रॉगली वेव्हज ऑर मॅटर वेव्हज. त्याचं एक्सप्रेशन आपण कसं काढलं तर पहिल्यांदा आपण क्वांटम थिअरीचा यूज करून फोटॉनची एनर्जी आहे जी आपण इक्वेशन मध्ये मांडतो, दॅट इज इक्वल टू h nu किंवा hc by लॅम्बडा असं आपण म्हणतो. Einsteins theory जर बघितली एनर्जी मास इक्विव्हॅलन्स तर आपण इक्वेशन लिहितो E is equal to mc स्क्वेअर. या दोन्हीचं जर आपण कंपॅरिझन केलं तर आपल्याला इक्वेशन मिळतात दॅट इज लॅम्बडा इज इक्वल टू h बाय mc, लॅम्बडा इज इक्वल टू h बाय p, वेअर p इज mc किंवा त्यालाच आपण mv असं जर कन्सिडर केलं, मटेरियल पार्टिकलचं मास आणि वेलोसिटी जर कन्सिडर केली तर आपल्याला व्हॅल्यू मिळते लॅम्बडा इज इक्वल टू h बाय mv, ज्याला आपण म्हणतो डी ब्रॉग्ली व्हॅल्यू. So up to this point we have discussed the basic terms, that is what is meant by photon, then photoelectric effect, its equation, its properties, its condition by different waves and different entities, that is frequency is there, intensity is there, potential is there, what is meant by threshold frequency, that we have discussed. Now after that we have discussed the dual nature of this light and we have added the de Broglie wave. We got this equation that is lambda is equal to h by p or h by mv. Now let us discuss the MCQ, that is second part, that how we can use these equations, these concepts while solving the MCQs, different MCQs. So let us start with the first one. When light of wavelength 300 nanometer falls on a photoelectric emitter, photoelectrons are liberated. For another emitter, a light of wavelength 600 nanometer is sufficient for creating photoemissions. So what is the ratio of the work function of the two emitters? So right now we have checked the equation for work function. So the solution is, after comparing this equation, we can get the value as W1 lambda 1 is equal to W2 lambda 2. So we have values of wavelengths. So lambda 2 upon lambda 1, if we put the values, that is 600 and 300 nanometer, we got the ratio, that is W1 by W2 as 2 as to 1. So simply answer is answer is B, that is 2 as to 1. We are comparing. So let us go to the next one. If the radiation is incident on the metallic surface of work function, so work function value is given, that is 1.32 into 10 raised to minus 12 joule. What is the threshold frequency? That is the threshold frequency should. So threshold frequency we have to determine. So work function, that is W is nothing but h nu 0. So we know the values of W and the value of h, that is constant. So after putting these values, we can get the answer, that is 2 into 10 raised to 21 hertz. We go to the next. Next is radiations of 2 photons energy twice and 5 times the work function of material. So the radiations of 2 photons energy is twice, that is 2 times into W0 and 5 times into W0 times the work function of metal are incident on the metal surface successively. The ratio of maximum velocities of photoelectrons emitted in two cases is. So we have to determine the ratio of maximum velocities of photoelectrons which are emitted in these two cases. So if we compare, that's kinetic energy 1 and kinetic energy 2. So simply the given values are the work function, which are twice and 5 times the work function. If you put the value, we can get the comparative point as W0 and 4 into W0, that is work function. So from equation 1 and 2, if we compare, we can get simply the value as V2 is equal to 2 into V1, or V1 by V2 is equal to 1 half. So from these things we can easily determine the answer. So let us move to the next MCQ. If ultraviolet radiation of 6.2 electron volt falls of an aluminum surface, then kinetic energy of the fastest emitted electron is. So work function is also given to us. So it is simply using of the equation what we have discussed already, that is kinetic energy max is nothing but h nu minus work function, that is W0. So if you put these values and after conversion we are getting the answer, that is 3.2 into 10 raised to minus 19 joule. So once we know the equations, whatever the MCQ is there, we can use the given values, we can find the values and we can get the answer. So let's move to the next. If the energy of a photon is 10 electron volt, then its momentum is, so we have to determine the momentum, that is value of P, as we have discussed right now, that is P is equal to h by lambda. So that momentum we have to determine. So if we compare these equations, so we can write simply E by C. E by C, value of C we know that 3 into 10 raised to 8. Value of E is given to us, we have converted, that is we are adding this factor 1.6 into 10 raised to minus 19 and we can get the answer. So the thing is that we have to know this equation, that is momentum, we can write by h by lambda, but here we have converted that into h into E by h into C, or simply E by C. So let us move to the next one. A metal surface is illuminated by the photons of energy 5 electron volt and 2.5 electron volt respectively. The ratio of their wavelength is. So for that we have to write this, or we have to know this equation, that is energy is nothing but we are writing that as a hc by lambda. So h nu is equal to h nu, from that we got this equation. So when we are using this one, that is E1 is equal to hc by lambda 1, similarly E2 is equal to hc by lambda 2. If we compare this, we can get lambda 1 by lambda 2 as E2 by E1. Energies are with us, that is for E1 it is 5 electron volt, for E2 it is 2.5. So if we put the values, we can get the ratio as 1:2. So let us move to the next one. The work function of a substance is 1.6 electron volt, that is the value of W we have. The longest wavelength of light that can produce photo emission from the substance is. So we have to determine the wavelength. So we can simply put the values, that is lambda 0 is equal to hc by work function. Value of h and c are nothing but constants. Put the given value of work function by adjusting the term and convert that into angstrom, that is 1 into 10 raised to minus 8 centimeter. 1 angstrom is equal to, so after conversion we can get the value of lambda as 7734 angstrom, which is the option D. Next, the energy of a photon for a wavelength of 4000 angstrom will be. So the energy we have to determine, so E is equal to h nu, or simply E is equal to hc by lambda. So put the values, it is just like previous one, put the values and we can get the answer, that is 3.09 electron volt. Okay, so let's move to the next. If the energy of a photon corresponding to wavelength of 6000 angstrom is 3.32 into 10 raised to minus 19 joule, the photo energy for a wavelength of 4000 angstrom will be. So here once again we are comparing the two conditions and determining the value of E. So if the energy of a photon corresponding to wavelength, for wavelength 6000 angstrom, energy is 3.32 into 10 raised to minus 19 joule. So the photo energy for a wavelength for wavelength 4000 angstrom, we have to determine the energy. So if we compare the equation, we get E2 by E1 is equal to lambda 1 by lambda 2. We have value of lambda 1, lambda 2 and E1. After putting, we can get the answer, that is 4.98 into 10 raised to minus 19 joule. So let us move to the next one. The wavelength of a 1 kilo electron volt photon is 1.24 into 10 raised to minus 9 meter. What is the frequency of 1 million electron photon? So for that, we know the equation, that is E is equal to h nu, where we have to determine frequency. So if you put the value, that is E, so here 1 into 10 raised to 6, we are determining, adding the factor. So 1 into 10 raised to 6 is nothing but 1 million electron volt. So for million, we are showing 10 raised to 6 factor divided by Planck's constant. So simply we are getting the approximate answer, that's 2.2, 2.4 into 10 raised to 20 hertz. Next, when light of wavelength 2000 angstrom is incident on tungsten, the maximum velocity of photoelectrons ejected is observed to be, its value is 8 into 10 raised to 5 meter per second. The threshold wavelength for tungsten is, the threshold wavelength for tungsten we have to determine. So how we can determine that? So we know the equation, that is, after adjusting, we are writing this, it's W is equal to hc by lambda minus 1/2 mv square. From photoelectric equation we are determining, so hc by lambda 0 we have adjusted here, and after putting these values we can get the answer of lambda 0, that is 2828 angstrom. Next, work function of tungsten and sodium are 4.4 electron volt and 2.3 electron volt respectively. So work function for two different material, that is tungsten and sodium, is given. If threshold wavelength of sodium is 5460 angstrom, then the threshold wavelength of tungsten is. So for tungsten, we have to determine the threshold wavelength. As we know that work function is reciprocal or inversely proportional to wavelength. So after comparing the equation for tungsten and sodium, we get lambda 2 by lambda 1 is equal to W1 by W2. So lambda 2, that is threshold wavelength of tungsten, we have to determine. So remaining values are with us. Put the value, we can get the answer, that is 2854 angstrom. So let us move to the next one. Two photons of energy 1 electron volt and 2.5 electron volt falls on a metal surface of work function 0.5 electron volt. The ratio of maximum kinetic energies emitted is. So maximum kinetic energy we have to determine. For that, we are putting the values of H1 and W0, and we are determining the ratios. As W0 is same, we are putting the values, and we can get the ratio as 1:4. So next, light of wavelength 4000 angstrom is incident on a metal plate with work function 2 electron volt. The maximum kinetic energy of the photoelectron is. So maximum kinetic energy, that is 1/2 mv square max. We know the equation, which is equal to hc by lambda minus W0. So we are considering this equation. The values are with us. After putting the values calculation, we can get the answer as 1.1 electron volt. Next, in an X-ray tube, electrons bombarding the anode produce X-rays of wavelength 1 angstrom. The energy of an electron when it hits the anode is. So we know the equation, E is equal to h nu, that is E is equal to hc by lambda. Value of h we are putting, c we know, and lambda is 1 angstrom, that is 1 into 10 to minus 10 meter. So after putting the values, we can get the answer. So this is our last MCQ. So different points we have discussed, and from that we have observed that if we know the basic equations related to photoelectric effect and for de Broglie wavelength or de Broglie wave, then we can easily solve these MCQs. So we conclude here. Thank you for listening and watching this video lecture.